Now we're doing FreeCodeCamp Legacy Python for everybody. Relational databases, many-to-many relationships. All right, so let's make sure we have our notes out to start. All right, we got a little Python notes right here. And let's go down here to where we left off. This little SQL stuff. Pretty interesting so far. Let's take this 1011, bring it down here, so that we can parse this thing later using this 1011 and 1013 and whatever this format. Come down here and let's get going.
So our last major topic is called many-to-many relationships. And
okay. Anyway, whatever. All right, so let's get back here to the Python notes and let's write this down. Many-to-many. Many-to-many many relationships. All right. So let's go.
Up till now, everything that we've done is what's called a one-to-many relationship.
Okay.
And that is, there are many tracks associated with one album. There are many albums associated with one artist. There are many tracks associated with one genre. And you can think of labeling, and as you look at data models, they put little labels on each arrow that tell you which end of the arrow is the many and which end of the arrow is the one. And so in this case, the foreign key is pointing to, there are many of these rows over here, many rows that point to one row over here. So it's a many-to-one relationship. There are various ways. Sometimes I'll put two arrows at this end and one arrow at that end. But whatever it is, this kind of thing we've been showing is a many-to-one relationship. And that's probably the most common thing. But there are times when you just can't model things with a one-to-many relationship. So like if you have a mother and children, well, that's a many-to-one relationship, and it's just fine, and that works fine. But sometimes you have a many-to-many relationship in that there might be many books. One book has many authors, and each author has many books. And so you don't have like the one side. There's no one. And so you have to end up building a table that I call it a connector table. They call it a junction table on Wikipedia. But we need a little table that allows us to break a many-to-many relationship into, in effect, two many-to-one relationships in a connector table. And so this is a connector table. So you could think of this as, there are many links here, but we don't have a way to model the many over here to here. And so what you do is you basically say, oh, there's a lot of these things. There's many that go to the one, the many that go to the one, and then in here you sort of create that manyness that you want to create. So it's probably just as easy to look at a sample of this.
Whoa. Let's type this down before we go too wild. All right, so let's type this down. But ciao. And we don't need to write many-to-many because we already got something else written down that's very close to it. Give me a second. Pardon me. All right. So sometimes we need to model a relationship that is many-to-many. Many-to-many. How many-to-many? All right. We need to add a connection table with two foreign keys. Okay, we'll see how that works. There is usually no separate primary key. Okay. And that's just like what he just said. All right, so let's go forward. Let's go forward with this action. Thusly.
So let's imagine a learning management system where you're taking a class, and there are some people that are teachers and some people that are students, and many students are members of many classes. A student can be part of many classes, and a class has many students in it. So you can't really find the one end. And so what we do is we make a table called membership. And in that table of membership, we actually often don't put a primary key in at all. We simply put in 2 foreign keys. And if we're going to put a uniqueness constraint, we put a combination of the 2 foreign keys as the uniqueness constraint. So we say,
what does that mean?
Duplicate user IDs.
What's a consistency constraint? Whatever you said. Consistency constraint? What is uniqueness?
As put a combination
uniqueness
of the 2 foreign keys as the uniqueness constraint.
So they're just making sure that they're all unique that go in here, I guess. We'll see.
So we say there can be duplicate user IDs and duplicate course IDs, but there can only be, user ID, course ID combinations. That has to be unique. So you can make unique be more than one column. And so if you imagine a course table and a user table, there's a user ID, the name and email, and the course has a title and an ID. And then we have this little table that just is the connector table that shows the points out. And so we can expand this membership. So let's take a look at how that works.
Let's do that.
So we're going to create some tables, and these are very classic tables because these are the one end of it. So these are the one end of it. So it has a primary key, a title, a logical key, email. There's a primary key for course, and then there's text. So we add this unique to kind of indicate that it's a logical key. We're not going to allow ourselves to put any duplicates in here. Now the connector database here is a table member, and it has 2 foreign keys, user ID and course ID. And you can even model some data here. So I'm going to model role, which is going to be 0 equals student and 1 equals instructor. And then I'm going to indicate that the primary key or uniqueness constraint is the combination of the user ID and a course ID. Now when we say the primary key, it both limits our ability to insert duplicates, but it also...
Okay, so before he keeps rambling on in his incoherent jargon that we don't understand, maybe you understand, but I don't. Just remember, this is the end of the course, right? Basically, we've got one section left. Remember, even though he's yammering and will not stop with the jibber jabber, at some point when we see this going on and we do it ourselves, we will figure it out. Because right now, he's just listening to himself say these words that only he knows. He only knows that he's the only one in this conversation right now, in this lecture, that knows what he's talking about. We have no idea what the H this guy's saying, but we will get it soon enough. Let's keep going.
Also allows the database to optimize its scanning because it knows that combination
blah
is
blah 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 blah. Oh, okay.
And storage structure to understand how to look things up more efficiently.
Turns out,
once it's found a user ID, course ID combination, it doesn't have to look any farther because they're unique. And so all of these contracts that we add speed things up, save storage, and makes things more efficient, but in ways we don't always know exactly how they happened.
Yeah,
and so let's go ahead and make these.
All right, so let's do what he's doing now. Actually, let's see. He might open up PY4E. Let's see.
Let's go ahead and make these guys. I think I will start with a new database.
Okay.
I'm going to call it
Teachers.
LMS for Learning Management System.
Okay, we can do that soon. All right, so let's go over here and pop that open. We got the DB browser. Cha-ching. Open her up. New database. Where are we? Browser for SQLite. Try our SQLite. Here's SQLite. Let's call this one Learning Management System. Learning. Let's go. Management System. Although I don't know what the naming convention for databases is. Learning Management System. I don't know. Let's just do it like that. All right, so we got this. Let's see what he does next.
No, I don't really want to do that one. And so I'm going to not create the table. I'm going to do everything in SQL.
Cool.
And so
We can
let
do
me
that.
see if it's in my cheat sheet. Nope, that's not in my
Nope.
cheat sheet. So I'll have to fix the cheat sheet again for you. By the time you see the cheat sheet, all these things will be in there. So I'm going to go in.
Hot sauce. All right. I don't remember where the cheat sheet was. PY4E. Let's do it. PY4E materials. That's good enough. Let's go over to lessons. Chapter 16, even though we're on 15, but they broke these two up. Chapter 16, down here to Python for Everybody database handout, Bachow. And we should be somewhere around here. So let's watch him do it, and then we'll figure out what he did. I think it's right here, many. I guarantee it. That's it. Anyway, so let's go. Where are we? Here.
Again for you. By the time you see the cheat sheet,
Thank you,
all
Chuck.
these things will be in there. So I'm going to go in here, and I'm going to grab create table user. Actually, I'm going to grab them all. Watch this.
Let's see. See what you got.
Grab them all. Highlight all these. Go over to SQLite browser. Blast them all in.
Blast them
and then
in.
I'll put a semicolon at the end of each one of the statements.
Wild man. Wild man over here. Wild man. All right, let's be wild as well. Oh, look, the semicolons are already here. We don't even need to do nothing. All right, so let's grab this little copy. Pardon me. Let's come over to SQL database. I didn't say data. I did say what I said, but I didn't mean it. Let's go over to execute SQL. Boink. And they already have the semicolons. So we should be good to go. Let's do a Control R. And let's watch some more video and see what he does after he does the Control R.
So does it look good?
Does it?
Yep. So I got.
Does it though? For us? Indeed it do. All right, so let's go.
A course. I got membership, 2 foreign keys, and I got user. So that all looks good.
Fantastic.
Okay. So now we're going to have to insert some data in.
Let's do that.
And we're going to insert from the outside in. And so we're going to just put the name and email. The ID will be automatically assigned for the users. And we're going to do the same thing. And the ID and the courses will be automatically assigned. So let me just grab all this stuff.
Yeah, let's do that while we're at it. Escape. Come over here. These 6 lines right here. Right there. Copy them. They all have semicolons. So, and they all have, there's all semicolons there. So let's just come over here to SQLite, execute SQL, Control A, Control V, Control R. And that should be good. It says insert blah, 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 finish without errors. So let's watch the video.
Go into SQL. That has the semicolons at the end already for me. Thank you very much. Now I'm going to run it. And if I take a look at my data, now I've got primary keys for.
Yeah, let's go look at our data. Browse data. We also have Python, SQL, and PHP. Okay, let's go.
For the courses, and I've got primary keys for the users, and I've got nothing in the membership table.
Ah, it turns out we can do that. So let's go do that. So we've got course here, Python, SQL, PHP, member, nothing. User, Jane, Ed, and Sue all have Sugi.org. Sugi.org. This better not be some weird stuff. I'm going to put it over here. Okay. Okay. It wasn't any weird stuff. Any stuff that'll get me thrown out. Documentation. Sugi Cloud. Developer tutorials. This looks just like... is this a learning management system? This looks just like PY4E. Doesn't it? I mean, it does, obviously. Look at that. Bajow, look, same thing. Same thing. Turns out. All right. Well, Sugi. Okay. Anyway, that reminds me, like, whenever you see, I don't know if you guys ever watched Tyler One, the League of Legends streamer. That guy is such a liar. He's such a, I mean, like, clearly he's a liar. He says he's 6'5" and everybody knows he's 5'6", but he will come on there and he will say, "Oh yeah, you ever heard of this thing called anime? Bro. Okay, we know you know what anime is, bro. We know you be watching it with your wife on certain days. Who knows what days they are, but they are certain." Sugoi.
And I of course have to remember what these values are, because Jane is 1 and Ed is 2 and Sue is 3, right? And Python is 1, SQL is 2, is 3. And so when I go into membership, I've got 2 foreign keys here and a role, and they just have to be for the course person combination. And so it's a little tricky to figure all this stuff out. But again, these are just numbers. And if you look at these numbers, user ID, course ID, role, well, user ID 1 is in course 1. User ID is in course as the teacher. User ID 2 is in course 1 as the student, et cetera, et cetera, et cetera. So I'm making these connections by just putting these little numbers in. And once again, conveniently, I have all my semicolons perfectly in place.
Pardon me. Yes, convenient. How convenient. All right, so let's go conveniently make this happen. How many is he doing? Hold on, let's go back one. That looks like 7 rows. I think we got 7 rows right here. 7 columns, 7 rows, yes. Copy it with a Control C. Let's go over to our SQL. Come to execute SQL. Do Control A, Control V, Control R. Control R for run it. And look at there, we got something. Let's see what we're supposed to do with it.
So I go to SQL. And then I run that. And then I take and I look at my membership data, and there it is.
Wouldn't you know? And it's all foreign keys. None of it is primary keys. It's all foreign keys. That's why they all got the numbers. Beautimous. I love it. I think it's fantastic. Haha, yes. Except for we've got those zeros. He's got zeros. Okay. So yeah, there we go. 0 is student and 1 is toucher. Oh, I meant teacher. Although I'm not, look, anyway. 2
foreign keys and a bit of data modeled at the connection. That's the way we say that. The role is modeled at the connection. So now we build all this stuff up, we can write some queries that take a look at this. And so what we're going to do is we're going to look at who's in what course and what role are they, and we're going to sort this in a nice way. So let's just take a quick look at the code we're writing.
What is that?
We're going to do a select from 3 tables, the username, the member role, the course title. So in effect, we're not showing any of the foreign keys or the primary keys. We're going to go from the user table, join to the member table, join to the course table.
Okay, let's write this down, and let's call it. Whoa, that's not right. Let's call it something. Once I start writing it down, let's call it something. Let's get it open. No notes right here. Example. Let's just say example. Example code. Example code. Boom. And do this. All right, so let's write that down. Let's get this database thing out of the way. And let's do this. So we're going to start with select user.name member.role course.title. All right. Whoa, from user join member join course. Oh, that's cool, I guess. Okay. We'll go over this. On member.user_ID equals user.id and member.course_ID equals course.id. order by, I don't remember doing that. Order by course.title member.role descending roll descending user.name. Okay, let's go.
This is pretty easy to write. You know there are 3 tables you want to go across. The on clause is also very easy to write, right? The on clause models each of these connections where the member's user ID is equal to the user's ID and where the member's course ID is equal to the course ID. So we're going to concatenate all 3 of these tables together, but we're going to only keep rows where it matters. Now that this role doesn't participate, but we're going to print that out. And we're going to order it by the course title first, and then the member role second, and the name third. And so let's run that.
Yeah, let's run that. All right, so we got that written down, but let's go snag it from over here because it's not formatted. This is formatted differently. All right, so let's grab it over here. Open that. Let's come over here to SQL. Let's execute the SQL. Let's Control A, Control V, Control R, and we can see what? Oh, it's going by title first. Isn't that what we said? All right, it's going by title first, so PHP, Python, and then SQL. And then it's going by role descending. All right, so we've got the teacher first, and then the student, teacher, student, student, teacher, student. And there we go. Anything else? That seems like it. Username. Huh? Oh, and then by the username. So we got add first and then Sue instead of Sue and then add, because add is E is before S in the alphabet. Although Ed is also a student in Python, but a teacher in PHP and SQL. How interesting. All right, so let's go.
So we've reconnected it. So Ed is the teacher of the PHP class. Sue is the student in the PHP class. Jane is the teacher in the Python class. Ed's a student, and Sue are students in the Python class. Ed's the teacher in the SQL class, and Jane is the student in the SQL class. And so we have many people there are many students in many classes there, and so we have modeled that, but we model that with this sort of table. And if you look at a piece of software that I've written called Sugi, which is a standalone learning management system that's built with learning tools, you will see in anything we're in membership where we have a user table, we have a context which is also the course table, and then we have a membership table. And you look, here's these foreign keys. It's kind of like that's the many side, that's the one side, many to one, and so this, this is
whoa there, Chief. What are you talking about, many to one when there's? Is that really how that is? I guess he's the boss.
In effect, a many-to-many between these two, but then it's modeled as a series of many-to-one relationships. And you see this all the time in all kinds of things where membership or other kinds of things are necessary, many-to-one, or many-to-many.
Okay. All right, before he goes and starts telling us about this, let's write this down so we know what he's talking about when he starts talking about it. Complexity enables a speed. Is that true? Complexity enables speed. Let's drop it down one more. All right, so does that mean the more complex it is, the faster it is?
So,
whoa. I know you're tired, Chuck, but we're all tired. We're all alive. All right, let's do this. Complexity makes speed possible and allows us to get very fast results as the data size grows. Complexity makes speed possible and allows us to get very fast fast results as the data size grows. Okay, I like that. I like that. By normalizing the data and linking it with integer keys, the overall amount of data which the relational database must scan is far lower, that's a long sentence, isn't it, than if the data were simply flattened out. Okay, what? So by normalizing the data and linking it with integer keys, okay, the overall integer keys, is that the foreign keys, right? Okay, the overall amount of data which the relational database must scan is far lower than if the data were simply flattened out. Normalizing. All right, we'll take your word for it. And then the next one is, it might seem like a trade-off. Isn't it a trade-off? Isn't everything a trade-off? What? It's best practice to spend time designing our databases so they continue to be fast when our applications are successful. What? It might seem like a trade-off. It's best practice to spend time designing our database so they continue to be fast when our applications are successful. Okay. Oh, so when our apps blow up and we get millions and jillions of viewers or users, it'll run like a dream, even with a bajillion users. I think that I know that's what that's saying. Let's go.
With all that, there's so much to learn.
All right, back it up.
So, with all that, there's so much to learn. It's
so much
easy and complex at the same time. It's easy when someone shows you how to do it, but at some point you will learn how to build database models, and you realize, oh, it wasn't so bad. It takes a while to get used to them. This really just is a quick walk. It is. The bottom line is, what we just did seems like it was, wow, that's nice. Do you really have to do that? And the answer is, if you're going to scale at all, you absolutely have to.
Absolutely.
You simply can't read and write data sequentially. You can't read through, update one little piece of data in a file by reading all the way through and then writing a new copy of the file. That could take seconds. And in a system like an online system, you get 1/100th of a second to do something like that. And the databases make it so that happens in 1,000th of a second. So you ultimately simply have to take advantage of this. You just can't, if you're going to modify data, you can read data from flat files, but even if you're going to read a lot of data, if it's big, it slows down terribly. So it might seem like there's a trade-off that you could debate whether this is worth it, but if you're going to deal with a lot of data, you've got no choice. It's really not as much a trade-off as you think. So
I think it is a trade-off. I think the trade-off is you do it, and if you don't do it, you're screwed, and if you do it, you're not screwed. So the trade-off is, be lazy, get screwed. Be diligent, don't get screwed. That's clearly a trade. Everything's a trade-off. Everything is a trade-off. Every decision you make has advantages and disadvantages. All right, and you have to match your advantages that you want, the advantages that it has, with the goals that you have. Or something like that. I know you understand. All right, let's write this down. Additional SQL topics. Where you at? Where you at? Notes. There you are. There you be. All right. Additional SQL topics. Let's do that. Additional SQL topics. And we're going, I've already decided, I don't think I've said this on a video or recorded before, but we are going to be going into SQL at some point. Probably right after we finish the beta Python, we'll go into SQL because we need to know this. I think that database, knowing how to do these databases is probably a little bit more important than actually knowing. I think they're on the same level as knowing programming languages and the techniques involved. All right. So we're definitely going to be going into SQL at some point, hopefully by the end of the year. So let's write this out. Additional SQL topics. Indexes improve access performance for things like string fields. Stringfield, Illinois. Just kidding. Constraints on data cannot be null. Yeah. Etc. So those things. Let's put a third. Let's make it a true ellipsis. And then we also got transactions. And these are gonna allow SQL operations to be grouped and done as a unit. Okay. So there we go. Let's see what else we got.
Oh, this has been a quick romp through databases. We talked a little bit about indexes. There are constraints. We talked a little bit the not null stuff. We've talked about that. Uniqueness, that's a constraint. Another whole area is what's called transactions, and that's the locking of little areas. So you can read an area, then lock it, and then update it to make sure no one else reads it. And so they make sure they either get the version before you looked at it, or before you change it, or after you change it. And so that's how you make sure that you can't do things having to do with bank account balances and get yourself in trouble. So these are a lot of SQL. It's really fascinating. SQL is a fascinating thing to use and learn and performance tune and enjoy. So,
here we go. This is the sign that we're about to be doing some exercises. All right, let's do summary. So, relational databases allow us to scale to very large amounts of data. True. The key is to have one copy of any data element and use relations and joins to link the data to multiple places. Yes. This greatly reduces the amount of data which must be scanned when doing complex operations across large amounts of data. Yes, because instead of strings, we're just using integers, single to triple, maybe even 5 digits integers, but that's a lot less than 20 characters in a string. Anyway, let's go. Database and SQL design is a bit of an art form. I'm not gonna add that. I think it's more of a craft, but whatever. How you doing today, Cyber Wealth Academy? Welcome to the stream. So there we go. Art form, maybe it's art. I don't think it's art, honestly. I think it's craftsman. I think it's craftsmanship, honestly. But let's go.
Relational databases are cool. This gets us started.
I agree.
The big thing is don't allow replication vertically of string data. Pull that out into a separate table.
True.
Establish a primary key, and then have foreign keys that point to that
True.
primary key. It is not just how much data you store. It's sort of a compression way, as a way of compressing data. You might think strings take no data, but they do. Numbers take a lot less data. And it's both how much data that's stored, but also how much data has to be scanned.
True.
And that way joins work. That's part of the magic of why Oracle is such a successful company.
No such thing as magic.
It's a bit of art form, and it's something
not
that
art.
you can work your whole life and always get better at.
I agree. I agree with that. I don't agree with the magic part, and I don't agree with the art part, but I do agree that you can go down the path of databases and never see the end. That being said, there's that. So now we're going to be going on to exercise email, and we'll see you next time.